16th one. See here also f of x is equal to -2, x less than or equal to -1, and -1 plus 1 they given. See here also let k be real number. If k is a real number, first we will take here case 1. So case 1 is we'll take here x is equal to k, which is less than -1. So less than -1 means f of k is equal to f of k will be constant function, means less than 1, less than -1. We'll take here -2 here. Limit x tends to k, f of x is equal to limit x tends to k, f of x is -2. Okay, so we'll get here -2 here. Therefore, limit x tends to k, f of x is equal to f of k. So f of x is continuous at x is equal to k, which is less than -1. Case 2. So case 2 is x is equal to k, which is equal to -1 we are taking here. So the first one is LHL. So LHL means -1. So less than -1 means, so we'll get here -2. So limit x tends to -1 minus f of x is equal to limit x tends to 1 minus f of x is -2. So we'll get here directly -2. Next RHL, if we'll take limit x tends to -1 plus f of x is equal to limit x tends to -1 plus f of x is, so -1 plus means greater than -1, that is 2x. You will get 2x. So 2 into wherever x is there, we'll substitute here -1. So this is equal to -2 we'll get here. So next one is value of the function, that is f of k is equal to k equal to -1 is equal to -1 is exactly -2 here. Okay, so all the values are same means, so LHL is equal to RHL is equal to f of k also. Therefore, f of x is continuous at x is equal to k, which is equal to -1. Next case 3 is, so case 3 is we are taking here x is equal to k, which is greater than -1. So greater than -1 means we'll take directly 2x value. So f of k is equal to directly we'll take here 2k. Next limit function, if we'll take limit x tends to k, f of x is equal to, so 2x means, so 2k you will get here. Okay. Therefore, limit x tends to k, f of x is equal to f of k here. Okay. So f of x is continuous at x is equal to k, which is greater than -1. Greater than -1. Next, fourth case if you will take, so that is, so case 4. So here we took x is equal to k greater than -1. Next we have to take less than 1. So x is equal to k less than 1 will take here. So f of k is equal to, so less than 1 value is, so less than 1 means 2x will get, so that is 2k will get here. Even limit function also, limit x tends to k, f of x is equal to, here also 2k will get here. Therefore, limit x tends to k, f of x is equal to f of k here. So f of x is continuous at x is equal to k, which is less than 1 here. So next case, fifth one is, so where x is equal to k and which is equal to plus 1 here. So x equal to k, which is equal to 1 value, we have to take LHL limit or HL limit and value of the function also. So first we will take here LHL. Limit extends to k minus. So k means that we will take here 1 minus f of x, which is equal to limit extends to 1 minus. So 1 minus means less than 1 means the function is 2x only. We'll take here 2x here. So if we substitute here 2 into 1, which is equal to 2, we'll get here left hand limit function. So RHL is limit extends to k plus. So f of x is equal to limit extends to k plus f of x is. So k plus means 1 plus, that is greater than 1. We'll take here 2. So we will get here 2 only here. Next value of the function f of 2 is equal, sorry, f of 1 is equal to, f of 1 value is equal to 1 means that is equal to 1 is 2x, no, 2x only. So 2 into 1 is equal to 2 will get here. So LHL is equal to, or HL is equal to f of 1 also. Okay. So f of x is continuous at x is equal to k, which is equal to 1 here. Next case, sixth one is, so we are taking here x is equal to k, which is greater than 1 here. So greater than 1 means f of k will be, so greater than 1 means we'll get here directly 2. Limit also, limit extends to k. F of x also will get here 2 only. Therefore, limit extends to k. F of x is equal to f of k here. So, f of x is continuous at x is equal to k, which is equal to, so which is greater than 1 here. So whatever values you can take, the function is continuous only. So f of x is continuous for all real numbers. Yeah. Next, 16th one is, f of x is equal to minus 2 if x is less than or equal to minus 1, 2x minus 1 less than x less than or equal to 1, 2 if x is greater than 1 here. See, here also we'll take here, let k be a real number. So case 1 is x is equal to k, which is less than minus 1. So less than minus 1 will take here. So value of the function, if we'll take f of k is equal to minus 2 only. Okay. See, okay, both are same problems. So we'll go for the next 17th one. Okay. Find the relationship between a and b so that the function f defined by f of x equal to ax plus 1 if x is less than or equal to 3, bx plus 3 if x is greater than 3 is continuous at x equal to 3. So here already they given the function is continuous at x equal to 3. So the function is continuous at x equal to 3 means LHL equal to RHL equal to f of x also. So given that f of x is continuous at x is equal to 3 here. So which means LHL is equal to RHL is equal to f of 3. Okay. So LHL means limit extends to 3 minus f of x is equal to limit extends to 3 plus f of x is equal to f of 3. Okay, so 3 minus means less than 3 means we'll take here ax plus 1 function here. So limit x tends to 3 minus f of x is ax plus 1, which is equal to limit x tends to 3 plus f of x is. So 3 plus means greater than 3. We'll take here bx plus 3, which is equal to f of 3. So f of 3 is less than or equal to 3 means we'll take here ax plus 1. If we substitute here in place of x3, we'll get here 3a plus 1 here. Now we can substitute here 3a plus 1 is equal to here also 3b plus 3 is equal to 3a plus 1. So all three are equal means I'm taking first two here. So 3a plus 1 is equal to 3b plus 3 here. Okay. So 3b you can send this side. 3a minus 3b is equal to 1 if we send that side. 3 minus 1 will get here. Okay. So 3a minus 3b is equal to 2 you will get. 3 minus 1 is 2 here. So now we need the relationship between a and b means, so we can be written as 3a is equal to minus 3b send that side. 2 plus 3b will get here. Therefore, a is equal to 2b or 3b plus 2 divided by 3 is the relationship between a and b. Therefore, this is the relation between a and b here. Okay. So next, 18th one. For what value of lambda is the function defined by f of x is equal to lambda into x square minus 2x if x is less than or equal to 0. 4x plus 1 is if x is greater than 0, continuous at x equal to 0. What about continuity at x equal to 1 here? So we are taking here x is equal to less than or equal to 0 or the continuous at x equal to 0 they given. So given that f of x is continuous at x is equal to 0 here. The function is continuous at x equal to 0 means LHL is equal to RHL is equal to f of 0 here. Okay, LHL is limit x tends to 0 minus f of x is equal to limit x tends to 0, RHL means 0 plus f of x is equal to f of 0. F of 0 means equal to 0. Directly we will substitute here. Lambda into 0 square minus 2 into 0 is 0 only here. So limit x tends to 0 minus 0 minus is less than 0. If you substitute f of x is, we have to substitute lambda into x square minus 2x here, which is equal to limit x tends to 0 plus f of x. So 0 plus means greater than 0 will take here 4x plus 1 here. Okay, which is equal to lambda into 0 minus 0 is 0. 0 into lambda is 0 only here. So if you substitute here 0 value, lambda into 0 minus 0 is 0, which is equal to, if you substitute here x value as 0, 4 into 0 plus 1, which is equal to 0 means leave it that one. So lambda into 0, so lambda into 0, which is equal to 4 into 0, 0, 0 plus 1 is 1 will get here. Lambda is equal to 1 by 0 we are getting here. Okay. So lambda equal to 1 by 0 we are getting here means therefore whatever 1 by 0 is not defined. So therefore any value of, therefore there is no real value of lambda. Lambda, the function is continuous at x equal to 0. So this condition is here x equal to 0 here. So if x equal to 0, so this condition is we are talking about only x equal to 0. So again, they are giving what about continuity at x equal to 1. So we are taking here if x is equal to 1. So if x equal to 1 means the function if we'll take here. So already we are taking here as continuous. So f of 1 if we'll take here. So f of 1 is the function is greater than 1. So greater than 1 means this is greater than 0 only. So 4x plus 1 only will take here. So 4 plus 1 means we'll get here, which is equal to 5 here. So the limit function, if you will take limit x tends to 1, f of x is equal to, here also limit x tends to 1, f of x is also 4x plus 1 only, which is equal to 4 into 1 plus 1 is equal to 5 will get here. So at x equal to 1, the function is continuous. So limit x tends to 1, f of x is equal to f of k here. Okay. Therefore, for any value of lambda, so there is no relation with the lambda here. So for any value of lambda, the function is continuous at x is equal to 1 here. Okay, any value you can take lambda, so the function is continuous only. Next, 19th one. Show that the function defined by g of x is equal to x minus greatest integer function x is discontinuous at all integral points. Here x denotes the greatest integer less than or equal to x here. So greatest integer function means whatever values you can take here, that value is greater than, is less than or equal to that number here. Okay. So given that g of x is equal to x minus greatest integer function x here. So we are taking here greatest function is the greatest integer function. Okay. So which means here, so whatever will take less than or equal to that number only. So which means greatest integer function of 4.3 value. So which means less than or equal to this number. So less than or equal to this number means we'll get here 4 only here. Even greater than or less than 4.9 also will take here 4 only. Even if we'll take 4.99 also will take here 4 only. So if you will get here 4 means you'll take it as 4 only. Why? Because this is greatest integer less than or equal to x here. So less than or equal to this number is 4 here. We'll take here 5.3. So 5.3 is nothing but 5 only. So this is the meaning of greatest integer function here. So g of x is equal to x minus greatest integer function x here they given. So now we are taking here k be any real number. So k be any real number if you take here. So what we'll get here? First we will find out limit LHL. So LHL is limit x tends to k minus f of x is equal to. So k minus means, so the function is less than minus 1. So less than minus 1 means we'll get here k minus. So limit x tends to k minus. So this will become, we'll write here as this function here. Okay, so this is negative means what we'll get here. So if you substitute k minus a k minus 1 will get here. So why? Because greatest integer function means, so negative values is nothing but we'll take less than 1 only. So less than that value. So we're taking k minus 1. So if you substitute here, minus into k is minus k, minus into minus is plus 1. So plus k minus k will get cancelled. We'll get here answer as 1 here. Next, RHL limit. So this is limit x tends to k plus f of x is equal to. K plus means we'll substitute directly k value only. So k minus k will get here, which is equal to 0 here. So LHL limit is 1, RHL limit is 1, 0 we are getting here. Therefore, LHL is not equal to RHL here. So the function is not continuous at any integer here. Therefore, f of x is discontinuous for all integers here. Okay, they're asking integral points means, so this function is discontinuous at all integer values. Next, 20th problem. Is the function defined by f of x is equal to x square minus sin x plus 5 continuous at x equal to 5 here? So given function is f of x is equal to x square minus sin x plus 5 here. So is continuous at x equal to pi they given here. First we'll find out limit value here. So first we'll take here at x is equal to pi. So which means f of pi will be, so wherever x is there, we'll substitute pi here. So pi square minus sine pi plus 5 here. So pi square value is pi square only minus sine 180 degrees. So sine 180 value will be 0 here. So minus 0 plus 5 will get. So finally we'll get here pi square plus 5 here. Next, limit function if you will find here, limit extends to pi, f of x is equal to. So limit extends to pi, f of x is x square minus sine x plus 5 here. So x square means we'll substitute pi here, pi square minus sine pi plus 5 here. We know sine pi value is 0, so 0 anything is nothing but 0 only. So pi square plus 5 only. So therefore, limit extends to pi, f of x is equal to f of pi. So f of x is continuous at x is equal to pi here. Okay.